Guys, good afternoon. Thanks for checking in. So I bought these 2 years ago thinking they were pretty interesting, and I never got around to trying them out. So maybe I'll just start by opening one of these up. These are digitally controlled resistors, and I bought them on eBay. So here they are. I forget how many ohms they are. There was a guy who had a similar chip. It was more of a dual inline package size, and he purchased them thinking they were 10 kilo ohm, and when he ended up doing a bench top test with his multimeter, they were 100 kilo ohm, so they were mislabeled. So anyway, maybe I'll get hooking up a microcontroller to one of these and make a bit of a module for myself. This is a module, but make a built-up circuit where I can control this with a microcontroller. We'll see where I get. All right, so off camera, I soldered all of the wire connections for this digital potentiometer. This side is the output, like the wiper blades, or not wiper blades, wiper pins, almost like a traditional twisty potentiometer, something like that. So there's 3 pins. I'm going to pause and look at a mode selection chart, which I believe appears in the data sheet. In fact, I pulled it off somebody's video. I'll get to studying the chip later on, but for now I'm just messing around with it. As it is now, I can get it to work, but it sweeps through the range of resistance values so incredibly fast that, well, let me just demonstrate. I'll get to showing the pinouts in a moment, but if I switch this low, it'll send a signal in on the up or down select pin. And then there's the ink pin, INC pin, which is kind of sets or increments. I guess that's an increment pin. And every time you push it, it goes from high to low. And it's supposed to go through the range of resistance values. But once again, if I tap the increment pin with a low, it's got to pull up resistor high on the increment pin already. But if I tap it to go low, it just sweeps right through the range of resistance values. I'll try to do it carefully. Hold on. So about 4 gentle button presses, and it sweeps right up to 10 kilo ohms, which is the maximum resistance that can be achieved. So if I switch this over, which is the up-down select, so it's gone 2 taps and it's gone right to less than half. That's about as low as it goes. And this should sweep up but 3 taps and I'm already at the top. So perhaps the button, the push button on the increment pin needs to be debounced, and perhaps rather than using my finger, I should be using some type of pulse generator. Maybe an Arduino, maybe a PIC chip, or maybe like a circuit that oscillates an on-off signal. And in a previous video, I converted this little toy into something like this, which is a pulse generator, so I might give this a try. So I've got 2 choices now, I think, to remedy this wide sweeping through the range. One is to put maybe a capacitor on the switch to get rid of the bounce in the switch. In other words, to debounce my switch. And I think another option might be to use a pulse generator. I will see. But before I do that, I will just show the mode selection sheet, which I printed off my printers. And away we go. So here it is here. All right, the chip is pretty small, but as maybe can be seen, the wiper blade or the wiper pins for the digital potentiometer are on the output. VH, VW, VL, the right side at the top, VCC, and ground are on the right and left side. Where's my pointy pencil? Hold on. Oh, here it is. So then there's three other pins of interest. I believe that's up, down, increment maybe, and CS. So the CS pin gets grounded with a low. The increment seems to be like, that's what I have hooked up to my push button, and it's currently sending a pull up high resistor down to a low every time I push the button. And then the up down select I have on like a slide switch, which I can select from high to low. So that's what's going on here. But once again, using a push button, especially with no capacitor for a debounce, is just sweeping right through the 10 kilo ohm range, whether I'm wiping up or down. After 2 or 3 pushes, it just sweeps right through the range. So I will go back to my breadboard. Here we go. Up, 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 up. So this monstrosity of a circuit here has all these slide switch pins, which I can switch from high to low. Actually, in this case, it's really just high or off. It's not connected to ground. But anyway, I've got a pull down resistor on the up or down, or the UD pin, which in fact is the green line. There's already a pull down resistor holding the UD low. Okay, so I took a little 104 capacitor, and from the increment push button, I have it sent back to ground here. So this actually did debounce my circuit. It worked. So just a little few taps, and it's gradually going down in resistance value. Now I have a cheap multimeter which doesn't have a very fast sample rate or perhaps refresh rate, so it's a little bit slow at adjusting, but I think you get the idea. Next, I'm going to see what happens if I put a pulsed signal in here. All right, so I took the push button out and replaced it with this pulse generator, which is producing square wave type pulses. It may as well be compared to like a 555 timer. It's doing the same thing. So this is the up-down select pin. It's currently set to high, which is wiper up, but the way I have my multimeter configured, it's a little bit backwards. So anyway, I'll just send the up-down switch, I'll toggle it, and hopefully it will be seen that the increment button is being pulsed with this device, and it's visible on the multimeter. So switching the up-down pin while it's incrementing. And back down. It might be fun to hook up an LED rather than the multimeter. I could keep the multimeter hooked up, but maybe we can dim and brighten an LED for the next experiment. Let's see. Alright, so the only way I was really able to show this effectively is to do this with the lights out. So now I will flip the up-down selection, and hopefully it will be seen that this white LED here just gets brighter. Okay, I got it to work better. Note to self to hook the LED up to the correct wiper pin. So now this should start brightening the LED. Okay, pushing now. Now I will dim the LED. Now. And brighten.
Alright, so I thought I would include at the end of this video some of the more detailed specifications. One reason this digital potentiometer is very useful is that if you need to control the voltage in a circuit by varying the resistance while the circuit is operating, then maybe such an IC is very useful. Of course, voltage can be changed in a circuit through the use of a voltage divider, so this resistor could maybe help do that. Apparently, the resolution of this chip is 100 divisions or steps, which can be applied to sweep through the range of resistance from 0 to 10 kiloohms. Now, what I didn't cover in my video is that this IC has a storage feature where non-volatile memory can be used to store a resistance value using the CS pin. And when you turn the power to the IC off and power it on again, it will remember that voltage level which has been selected through the use of the CS pin. You have to see the data selection in the selection modes to more clearly see how to select a resistance value. But when you repower the device on, it will revert back to this storage value which you have selected. Unfortunately, I didn't cover that in my video. And not only that, whatever value you select, it will add 100 ohms to that value. So far as I understand, the control cycle, which increments, shouldn't be less than 2 microseconds. I'll leave a link below for the datasheet, and maybe a few other links on this particular IC. Thanks for watching. If you liked this video, check out my other videos. Thanks. Have a good day.